Hey guys, welcome back. We would be talking about zero downtime deployments in Kubernetes. So Kubernetes is simply a container orchestration platform, you know, and we would be talking more about rolling deployments. So Kubernetes provides out-of-the-box support for rolling deployment through deployments. A deployment makes use of replica sets, which are replication controller capable of supporting set-based selectors. For orchestrating the pod deployment, a good example is when a deployment has been updated, a new replica set will be created based on your strategy, and the old and the new replica sets will be adjusted until the deployment has been finished. So the deployment provide us with the easy and effective way of rolling updates, but it doesn't provide a full solution to those who need zero downtime during the rolling of an update. During deployment, there is a need for us to ensure that there is no availability disruptions. For us to achieve, we have to address a couple of issues. Number one, connection draining. Second, HTTP keep alive. We would be talking more about first is connection draining. We don't need to have our container killed as the processes of in-flight request is being done. For us to do this, the following steps are necessary. Indicate that we do not need to receive more new requests. Be given time as to finish the requests which are currently being processed. With Kubernetes, we can add a readiness probe to the container. In case the probe fails, then requests to be sent to the service won't be routed to our container. The following can handle number one in the steps given above, as you can see where I'm pointing through my cursor. In the case of number two, the pending request should be given time so as to finish. So the Kubernetes will send a SIGTERM signal to the process of the container so as to instruct it to shut down in the right procedure prior to the sending of SIG-kill. The container has to be given a grace period, which is termination grace period second, so that it can shut down. So we can stick to this, and instead of having to handle the SIGTERM in our app, we add a life cycle hook. This is an indication that we will be in position to execute any arbitrary command, such as when we need to gracefully shut down our container. The example given below will fail the readiness probe simply by taking down a health check before Kubernetes can send the SIGTERM signal, which you can see here. Now, to keep HTTP keep alive, the connection draining given above will allow our in-flight request to finish. However, in cases where a connection string is using HTTP keep alive, the TCP connection will remain open and it will be used for other requests. For us to solve this problem, we are going to add a proxy tier for terminating HTTP connection, and it will proxy the request to the actual backend service, which are the containers. The proxy will make use of connection close with backends and others so that the requested processing can be made to be more robust. So example application, in this example we will be using a simple nginx container, which we have used earlier as well, which has two versions. On the home page, one will say red while the other one will say blue. The deployment will be tested by use of these two. We will also use a HA proxy container for the purpose of terminating HTTP connection found on our proxy tier. So creating the service, we will be creating the following two services. One is about my app, the application, and the other is my app -proxy for application. The my app proxy will be responsible for taking requests and then sending them to the backend, which the my app service provides. So we have to run the following commands for the purpose of creating these services, as you can in the screen. So now that we have created the service, there is there is a need for us to create the deployments for the proxy and the application. And now the next activity is to create the deployments. To do this, you only have to run the following commands, as you can see in the screen. So you should then have the deployments running after after a few minutes. For those who are making use of Minikube, just type the following and you will see the application. Once the browser has been opened and you will be red color on your screen, just type the following, and this Minikube has been explained by me in the earlier lectures. Now coming on to testing, you should now go ahead and obtain the my app proxy URL, since we will need it for testing purpose. We will now begin to make use of Apache Bench for sending traffic to the service, and the deployment will then be updated with a blue image. The use of -k flag will help us to test HTTP keep alive scenario. As the command runs, you should go ahead and run the following so that you can launch the rolling update. This you can see here. After that, just refresh on the browser and you will observe the red and the blue colors swapping on the screen. You will see it finally settle on the blue version. When you look at the Apache Bench this time, you will see 0 failed request. So I think I should take a pause, and in the next lecture I would be discussing or continuing with the same. So till then, stay tuned. Thank you.